Hi, let's talk about recursion. In this video, you're going to learn what recursion is, and you're going to see how it works behind the scenes with an example of the Fibonacci sequence. So, let's begin. First of all, what is recursion? Well, recursion means defining a problem in terms of itself. We're basically going to take an initial problem and we are going to break it into smaller versions of the same problem that we're going to solve individually. Once we have all the individual results, we are going to combine them and solve the initial problem with those solutions. The famous example that we're going to use to illustrate how recursion works behind the scenes is the Fibonacci sequence. This is a famous sequence that appears in nature very often, including spirals and the number of petals in a flower. This sequence is very famous. These are the first numbers in the sequence. Let's see the pattern that they share. The nth Fibonacci number, starting from 0, this would be the nth Fibonacci number, is a result of adding the two previous numbers in the sequence. Let's say that this is a function that finds the nth Fibonacci number. So this is going to find the n-1 Fibonacci number, and this is going to find the n-2 Fibonacci number. These numbers refer to positions. You can see this right here. The third value in the sequence, 1, is a result of adding the two previous values, 0 and 1. 0 plus 1, 1. Then 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And so on for the rest of the sequence. This sequence can continue as long as you need to. That concept takes us to another concept that we're going to use in our code, the concept of a recursive function. A recursive function is a function that calls itself. So you're going to have a call to the function within the function definition. Recursive functions are divided into two main parts. One of them is called the base case and the other one is called the recursive case. Let's see what each one does in the function. The base case is the condition that has to be true for the recursive process to stop, for the function to stop calling itself, because otherwise we would have an infinite process that would never end. The base case makes sure that we don't have that, an infinite process that never stops. And then we have what we call the recursive case. This is when the function is called recursively. The function calls itself, but this time it takes a smaller version of the problem. And that smaller version will eventually lead us to the base case, to make sure that the process will stop. It's like the Matryoshka dolls. We are breaking the problem down into smaller versions of the same problem, and then we're going to combine all of those elements to solve the large problem, the main problem that we had when we started calling the function. Here we have an example in code of a recursive function that finds the nth Fibonacci number. Let's start by looking at this right here, the parameter of the function. You know that the function is called Fibonacci. We define it using the def keyword like any other regular function. And we can start focusing on this parameter right here, n. Let's see the role of n in this function. N is the value of the position in the sequence of the Fibonacci number that we want to calculate. This starts from 0. So this n denotes the position of the number that we want to find. In this sequence, the Fibonacci sequence that we saw previously, the value of n is assigned to each one of these elements in the sequence, starting from 0. Then 1, then 2, then 3, 4, 5, 6, 7, and 8, and so on for every element in the sequence. If we want to find, for example, the third element in the sequence, we would have to pass n equal 2 as the argument. Now you know the role of n, so let's dive a little bit deeper into the structure of this function. Why is it recursive? Well, as you can see right here, we have function calls to the function itself. The function is called Fibonacci. And right here, we are calling the Fibonacci function in the function definition. That is why this function is recursive. These function calls are going to find the two previous Fibonacci numbers in the sequence. And then they are going to add those values because we have the plus sign, and they are going to return the result of the call to the Fibonacci function. Remember that this is the definition of the Fibonacci sequence. The nth Fibonacci number is the result of adding the two previous numbers in the sequence. So that is why we have to add these two function calls. We get the previous number and we get the other previous number, the two previous numbers in the sequence. This is what we call the recursive case because we have these recursive calls. And one of the key things about the recursive calls is that they solve smaller versions of the same problem. And that is what we achieve by modifying the argument right here. Notice that we get the value of n when we call the function right here. And when we make the recursive calls, we are passing different values to the function calls. Let's erase this so you can see this more clearly. We get n, but right here we are passing n minus 1. And right here we are passing n minus 2. That is exactly what recursion is all about. You call the function again, but with a smaller version of the same problem. That reduction of the value of the argument is going to take us eventually to the base case. The base case tells us that when n is either 0 or 1, then that exact value, the same value, is going to be returned. If n is 0, then 0 will be returned. And if n is 1, then 1 will be returned. That is the base case. Notice that right here we don't have any recursive calls. We only return a value, and that is when the recursive process stops. Now you know the structure of this function and the basic logic of how the recursive calls are going to work. So let's see this illustrated with an example, and let's see how it works behind the scenes, how these two values are actually computed. Right here we have a call to the Fibonacci function, and we pass 2 as the value of n. Right here, this will be the value of n. We are simply calling a function, and that function is going to make recursive calls. Remember that the count starts from 0, so we're actually finding the third number in the sequence because we start to count from 0. That third number in the sequence is 1, and that is the result that we are expecting from this function call. When we call the function, right here, the first thing that happens is that 2 is assigned to the parameter n, right here. Since this is a function definition, the first thing that's going to be checked is if n is either 0 or 1. Since this is not the case, the condition is false. And we go to the else clause. This line right here runs the return statement with the recursive calls. This is the first recursive call that we find, because expressions are evaluated from left to right. So this function call is going to start running, and the process of the main function call is going to be paused. This function call is going to wait until this function call is completed, because it needs to know the value of this function call, the value returned. This is going to be equivalent to calling Fibonacci of 1 in this case, because it's Fibonacci of n minus 1, and n is equal to 2. We are basically going to have a function call within another function call. The main function call is going to be paused until this internal function call is completed. Then, right here to the right, we find another recursive call. This time, we are passing n minus 2 as the argument. N is equal to 2. So, n minus 2 is equal to 0, the argument that we can see right here. So we are going to we're going to start these two function calls, and then we are going to add the values that they return. That sum is going to be the value returned to Fibonacci of 2. To get Fibonacci of 2, we call Fibonacci of 1 and Fibonacci of 0. So we have 3 function calls for this function call alone. For Fibonacci of 1, which is the first recursive call, the function is going to run again, it's going to start again, and it's going to check if the base case is true. In this case, it is because n is equal to 1, the argument that we have right here. So the value 1 is going to be returned. This, behind the scenes, is equivalent to return 1. 1 is assigned to the parameter and 1 is returned. Now we have the value of this recursive call. Right here, we can replace it in the original call. Return 1. Behind the scenes, you can imagine as if we were replacing this recursive call with the value returned by the function call. This right here would be replaced by 1, the value returned by calling Fibonacci of 1. This is what happens behind the scenes. You're not going to see this change or updated in the code that you're running. You're just going to see the function definition, but behind the scenes, that call is going to be replaced by the value. Now we have Fibonacci of 1 and we have the value that it corresponds to. So let's see how Fibonacci of 0 works, because we still need that value to find Fibonacci of 2. For Fibonacci of 0, what we have right here is another function call that is going to check if the base case is true. In this case, the base case is true because n is equal to 0, and the return value is going to be 0. Because 0 is assigned to the parameter n, and that value is returned. In this case, that value is 0. That is the base case. So now we have the two values that we need to find Fibonacci of 2. We have the value of Fibonacci of 1 and Fibonacci of 0. Right here, we can combine them. And how can we do that? We replace 0 right here. We replace the value of the function call behind the scenes, and then we evaluate this expression before returning the value. 1 plus 0 is equal to 1. And that is the value, the final value that is going to be returned for Fibonacci of 2. So now you understand how recursion works. Fibonacci of 2 has to call Fibonacci of 1 and Fibonacci of 0, and those values are combined to find the actual value of the main function call. Here we have the code in the interactive shell. We define the function Fibonacci, and here you can see the recursive calls. And if we call the function right here, you can see that the return value is 1, exactly what we expected, the third element in the sequence. And what do you think will happen if we have Fibonacci of 3? If we want to find the fourth element in the sequence, remember that we're starting to count from 0. Well, we would have Fibonacci of 3, and we have to find the value of Fibonacci of 2 and Fibonacci of 1. For Fibonacci of 2, we would have to call Fibonacci of 1 and Fibonacci of 0. Essentially, that is a recursive process. We need to find Fibonacci 1 and Fibonacci of 0 to find the value of Fibonacci of 2. And we need to find Fibonacci of 2 and Fibonacci of 1 to find Fibonacci of 3. Fibonacci of 1 returns 1. Fibonacci of 0 returns 0. These two values are added, and that is the value of Fibonacci of 2. The value is 1. Fibonacci of 1 is equal to 1 because the return value is 1. When we add these two values, the result is 2. And that is the value of Fibonacci of 3. The return value is 2. You can see it right here when we run the code in the interactive shell. Now you know how recursion works behind the scenes. Check out some more videos to learn how to code in Python and other programming languages, and subscribe to my channel to be the first to know when I publish new videos.